Hi. In this lesson, you will be learning about clouds, wind, temperature, and humidity so that you will better understand the observations and measurements that you will be making on your field trip. So let's get started with learning a little bit about clouds. First of all, what makes up a cloud and how do they form? Well, clouds are made up of tiny water droplets or ice crystals. They play a crucial role in the water cycle and in shaping weather patterns around the globe. Cloud formation begins when water from oceans, rivers, lakes, and surface runoff rises as water vapor, a process called evaporation. It also happens when water vapor evaporates from plants. This is called transpiration. The water vapor rises into the atmosphere and is invisible until it reaches a high enough altitude where the air cools. This causes the water vapor to change back into tiny liquid droplets or ice crystals. This is called condensation. These droplets or crystals then cluster together around tiny particles floating around in the air, such as dust, salt, or pollution. When this happens, we see clouds. But how do clouds make rain or snow? Sometimes air currents within the clouds keep the droplets or crystals moving around and bumping into each other. This can cause them to grow larger. As the droplets or crystals grow larger, they become too heavy to stay suspended in the air. When they are heavy enough, gravity pulls them down and they fall from the cloud. This is called precipitation. If the temperature is above freezing, precipitation falls as rain. If it's cold enough, it falls as snow, sleet, or hail. Now, let's talk a little bit about the three basic types of clouds and the type of weather that they are associated with. Cirrus clouds are thin and wispy and usually found high in the sky. They are composed of ice crystals and often indicate fair weather. Cumulus clouds are fluffy and have a cotton like appearance. They form at lower altitudes and are associated with fair weather. But they can develop into larger, more vertical clouds called cumulonimbus clouds. These bring rain or thunderstorms. Finally, stratus clouds are layered and cover the sky like a blanket. They often bring overcast conditions or light precipitation. These are only the basics. Clouds can combine to produce a lot of variations, and you will be observing and recording these types of variations for your field trip using a special smartphone app called Globe Observer. Well, given what you've heard so far, you can probably guess that clouds play a significant role in the Earth's climate system. They reflect sunlight back into space, which has a cooling effect on the Earth's surface. However, they also trap heat emitted by the Earth, contributing to the greenhouse effect and warming the planet. The net effect of clouds on climate depends on factors such as how high they are in the sky, their thickness, and their particle composition. So, we've been talking a little bit about sunlight, but it does beg the question, why does it feel warmer in the sun than in the shade? Well, when you stand in the sun, it feels warmer because of how sunlight interacts with your body and the surrounding environment. The sun emits energy in the form of light and heat. When sunlight hits your skin, it warms it up. This is similar to how a heater warms up a room. The sun's rays include infrared radiation, which is a type of heat energy. When these rays hit your skin, they make your skin cells vibrate faster, which generates heat. And also, your clothes absorb sunlight, converting light energy into heat. Darker colors absorb more sunlight, so they can make you feel even warmer. In the shade, you are protected from direct sunlight by an object that blocks the sun's rays, like a tree or a building. This object absorbs and reflects some of the sunlight, so less of it reaches you. As a result, you don't feel as much heat. Also, the air temperature is usually cooler because the sunlight isn't directly hitting the ground and objects around you. So, The temperature you feel is impacted by the amount of sunlight. But what about humidity? What exactly is it? Well, humidity is the amount of water vapor or moisture in the air. Imagine the air around you as a sponge. When the sponge holds a lot of water, it feels wet and heavy. Similarly, when the air has a lot of water vapor, we say the humidity is high. On the other hand, when there isn't much water vapor in the air, the humidity is low and the air feels dry. Now, two common ways to measure humidity are as follows. Absolute humidity is the actual amount of water vapor in the air. Think of it as counting how many drops of water are in a specific amount of air. Relative humidity tells us how full the air is with water vapor compared to the maximum amount it can hold at a certain temperature. So this is expressed as a percentage. For example, if the relative humidity is 50%, it means the air is holding half of the water vapor it could potentially hold at that temperature. On this field trip, you will be measuring relative humidity. Well, how is this done? Well, you measure humidity using tools that tell you how much moisture is in the air. In this module, you'll be measuring humidity using a simplified version of something called a psychrometer, which is a device that involves using a dry bulb and a wet bulb thermometer. How does humidity affect how we feel? Relative, relative humidity affects how hot or cold we feel because it changes how easily our bodies can cool down. When the air is humid, it has a lot of water vapor. This makes it harder for our sweat to evaporate. Sweating is how our bodies cool down. So if the sweat doesn't evaporate easily, well, we feel hotter than the actual temperature. For example, if it's like 85 degrees outside but very humid, it could feel more like 95 degrees. But when the air is dry, sweat evaporates quickly, which helps us cool down. This makes us feel cooler than the actual temperature. However, very dry air can also make our skin, throat, and eyes feel dry and uncomfortable. The heat index combines the air temperature and the humidity to show us what the temperature feels like. For example, if it's 90 degrees Fahrenheit with high humidity, it might feel like it's over 100 degrees. How does wind form? Well, wind forms due to several factors. The sun heats different parts of the earth unevenly. For example, the equator gets more direct sunlight than the poles, so it gets hotter. When the ground gets heated up by the sun, the air above it also warms up. Warm air is lighter than cool air, so it rises up into the sky. When the warm air rises, it leaves behind an empty space, creating an area of lower pressure. Cooler, heavier air from surrounding areas then moves in to fill this space. This movement of air from areas of high pressure to areas of low pressure creates wind. The bigger the difference in temperature and pressure, the stronger the wind. We also find it helpful to know what direction the wind is blowing. So, how do we measure this? Wind direction is measured using a weather vane. It consists of a rotating pointer that has an arrow or shape that is designed to catch the wind. As the wind blows, it pushes against the pointer, causing it to rotate. The direction the pointer faces indicates the wind direction. For example, if the arrow on the weather vane is pointing north, that means there is a north wind, i.e., the wind is blowing from north to south. Weather forecasters, otherwise known as meteorologists, use wind direction to get a sense of what kind of weather is coming. Generally speaking, cold air is located to the north and warmer air is located to the south. So if the weather vane shows wind blowing from the north, one can say colder air is probably moving in. This is especially true if the weather direction recently changed to the north. usually a sign that a cold front just passed by. Another important measurement is wind speed. How do we know how fast the wind is blowing? Well, one way is simply by observation. Let me give you some examples. If the weather outside is such that it is completely still, smoke would just rise straight up. But if there's a light breeze, like 1 to 3 miles an hour, it would drift in the direction of the wind. Trees or flags wouldn't move, however, because they are heavier and would need a stronger force to move. A light breeze of 4 to 7 miles an hour can be felt on your face. Leaves would rustle and a wind vane would move. Now, if small twigs are in motion, then it's a moderate breeze of 8 to 12 miles per hour. Flags will also extend out. Now, if the tree branches move and you hear louder rustling, that is a fresh breeze, 13 to 18 miles an hour. You will feel the wind stronger on your face and body, and it's a good time for flying kites. A strong breeze is 19 to 24 miles an hour. Tree branches sway vigorously and small trees begin to sway. You'll feel the wind pushing up against you. You might even have to hold on to a hat or a loose object to keep them from blowing away. Now, above this, you are starting to get into more gale force winds, which make walking difficult and conditions that can become unsafe. In fact, severe storm conditions start at anything above 47 miles an hour. So, observation is one way to measure wind speeds, but it isn't that exact. So, how do we measure wind speed using an instrument? Well, this is done using a tool called an anemometer. It can be one of two types. A cup anemometer is the most common type. It has 3 or 4 cups attached to the ends of horizontal arms. When the wind blows, it pushes the cups, causing them to spin around a central axis. The faster the wind blows, the faster the cups spin. The anemometer measures how fast the cups are spinning and converts that into a wind speed. Now, some anemometers are digital and use sensors to measure wind speed, so they're a little bit different. They might have small rotating blades or just use ultrasonic sound waves to determine how fast the wind is moving. To get an accurate reading, an anemometer is usually placed high up in an open area, away from buildings and trees that might block or slow down the wind. Now, you will be building a simple anemometer to get the idea of how they work, and you will indirectly be measuring the wind speed on your field trip. So, with all of this knowledge, it's time to put it to good use. So head to the field trip lesson and video to learn how to get ready to go.